In number 46, I meant to talk about this system of equations. If I'm going to talk about it, then I better put that talk inside of a sentence. There's a rule. It's not a hard rule that you always have to follow, but it's a rule. Like I before E except after C. That you shouldn't start any sentences with mathematical symbols. Here I'm starting with the symbol 7, it seems. So instead of that, how about if I start this sentence off by talking, let's see, what is the subject of the sentence? The subject will be this system of equations. Okay, so the system of equations and then there, that's a system of equations. And I want to rewrite them as a single equality. So let's see. This system right here, I'm going to group them together with that and then say is equivalent to. Now that is simply a short, that symbol right there really is shorthand for is equivalent to. It just is shorthand for those words. I could write IS space EQIVALENT space TO space and then whatever follows, or I could just write this symbol. It is only shorthand. It is not diagrammatic thinking, it is shorthand. Okay, is equivalent to, and you know what I can do is I can write a single equation between two vectors and between two, TWO, two vectors, two space vectors. Okay, as in two vectors. Okay. And this is what it'll look like. 7x minus 5y is equal to 2. So the first component on the left is equal to the first component on the right. And negative 3x minus 9y is equal to 2. Good. All right. So I have done what I've been told to do, rewritten the system of equations as a single equation. Now, what I could also say is this is equivalent to the matrix equation well, you know what I'll do? I'll slow down and I'll do things a little bit different. I will do this 7x negative 3x plus negative 5y and negative 9y is equal to 2. All right, so I just broke this 2 vector into 2 terms, the term with all the x's and the term with all the y's. And then you know what? That is equivalent to 7 negative 3 times x. I've simply factored out the x. This is scalar multiplication. And I'll factor out the y here. Negative 5 and negative 9 are what's left. And the other side of the equation stays the same. So once again, I am telling you that this statement is equivalent to this statement. And they're both statements. They're equalities, right? This thing is equal to this thing. That's a statement. Okay. Last but not least, we fulfill the last part of our instructions, or implement the last part of our instructions, trying to use better language. That is the way that we define the matrix 7, negative 5, negative 3, negative 9, better looking 7, times xy. So this is the function 7, negative 5, negative 3, negative 9, the function that we name that, evaluated at xy is equal to 2. That's a sentence. Now if you read it, it's quite a difficult sentence to read, and indeed even as the logic of it is quite difficult to follow. The system of equations, 7x minus 5y is equal to 2 and negative 3x minus 9y is equal to 2 is equivalent to the equation, the 2 vector whose first component is 7x minus 5y and second component is negative 3x minus 9y is equal to the 2 vector whose first component is 2 and second component is 2. Yes, see, it takes quite a bit of reading. Now, we have a wonderful collection of shorthand notations for all of these words, but they really are words, and you really can